Hello guys, welcome back to Techie Tech. Guys, through this channel, I will be discussing about various electronic components and at some point we'll be building projects with those. So in this regard, my first series of videos is going to be about Arduino UNO, which I have already started with the first part. You can check the playlist in the description. I also recommend that before watching this video, please go through the part 1 so that it will be easier for you to grab all those concepts, especially if you are new to this world. So moving ahead, in this part 2 of the video series, we are going to discuss about detailed pinout diagram of Arduino UNO and the respective functions of the pins. So without wasting any time, let's get started. We have already seen how Arduino looks and what are the components in the board in the previous video or part 1 of the UNO series. Here we have taken a virtual image of Arduino UNO for a better visual representation. There is not much a difference with the actual ones. In some boards, you may find a few extra pins here and there. In the previous part, we have seen what are the components present in the board. In this video, we will see what are those black female type pins and their respective functions. So let's start with the power pins first. We have already seen V-in and ground pin in the previous video. You can power the Arduino UNO board by any DC source like battery or adapter or any other sources through these two pins. Just connect positive of the source to V-in pin of Arduino and negative of the source to the ground pin. There are other ground pins as well. All these ground pins are internally connected to each other. We can use those to supply power to other components as well. Now let's see the 5V and 3.3V pin. As you have guessed already, these two pins can provide 5V and 3.3V power respectively to other electronic components. Don't forget to connect ground pin of that component to any of the ground pins of Arduino UNO. Now let's move ahead and have a look at other pins. But before that, keep in mind that many pins have more than one functionality. So don't get confused if I refer same pin in multiple segments. Let's start with digital only pins. As you can see, they are labeled as 0 to 13. These pins can only recognize plus 5V and 0V as high and low value and act accordingly. We all know that in digital electronics, there is only 1 and 0, that is high and low, or in other terms plus 5V and 0V, nothing in between. That's why these pins are called digital only pins. So these 14 pins can take input or provide output in digital forms only. That means they can either provide plus 5V or 0V, and at the same time they can only take input of plus 5V and 0V. Now there is a catch. You can see special mention of pin number 3, 5, 6, 9, 10 and 11. These are PWM pins. Although they can provide digital output only, but with the help of pulse width modulation technique, they can provide analog output as well. That means they can provide an average voltage of anywhere between the range of 0 to 5V. We will see about PWM technique in a separate video. Now let's move ahead to the analog pins. Now I hope you have understood the difference between a digital value and an analog value. For a recap, a digital value means either plus 5V or 0V. In the contrary, an analog value can be anything between 0 to 5V. Now these 6 pins A0 to A5 can take analog values as input. There are 6 analog to digital converters within the microcontroller chip attached to these 6 pins. When analog value is fed to these pins, the corresponding ADC or analog to digital converter converts that value to a 8-bit digital data. Now you may ask, why 8-bit? I already discussed in the previous video that the microcontroller of Arduino UNO is a 8-bit microcontroller. That means it can handle 8-bit data. Now coming back to the digital conversion of the analog value, which is then processed by the microcontroller. Let's see how this happens. As you are aware now, the maximum voltage that this board can take as input is plus 5V and the least voltage is 0V. Now maximum value of a 8-bit digital number is 8 ones, that means 1111 1111. That is 255 in decimal form. If you want a separate video on binary to decimal conversion, let me know in the comment section. and minimum value of 8-bit data is 8 zeros. that is 0 in decimal form. Hence 0 volt represents 0 in decimal form and 5 volt represents 255 in decimal. Now if you apply 4 volt in these pins, the corresponding decimal value will be 204. For 3 volt it will be 153. For 2 volt 102 and for 1 volt 51 and so on. It's just a simple proportion. If you convert those decimal forms to binary form, you will get a 8-bit digital equivalent of those analog values as shown in the screen. Now analog to digital converters finally sends those 8-bit digital data to the processing unit for further processing. Now keep in mind that though these A0 to A6 pins are called analog pins, they cannot provide analog output. Only PWM pins, as discussed earlier, can provide analog outputs. Now let's discuss about some special communication pins. Through these pins, Arduino communicates with other devices like computers, smartphones, other microcontrollers, output devices, sensor modules, etc. I already mentioned that some of the pins can perform multiple functions. The reason I am repeating this again is because all the communication pins can act as digital or analog pins that I already discussed. So first look at the digital pin 0 and 1. It can also act as UART receive and transmit pin when communicating serially with computers or other devices. UART means Universal Asynchronous Receiver Transmitter. During the communication, transmit pin of Arduino UNO is connected to the receive pin of the other device, through which Arduino sends data to that device, and the receive pin of Arduino is connected to the transmit pin of that device, through which that device sends data back to the Arduino. So this UART communication is a one-to-one communication that needs two communication lines. Keep in mind that as digital pin 0 and 1 acts as receive and transmit pin during serial communication, avoid using these two pins for other purposes while UNO is communicating with computer or other devices. So this UART serial communication is based on the TTL protocol. Now let's see how Arduino communicates with other devices over I2C protocol, also referred as I2C protocol. If you want a detailed video on I2C protocol, let me know in the comment section. Without getting deeper into I2C protocol, just remember that Arduino can communicate with multiple devices over same two connecting lines only. These are SCL or clock line and SDA or data line, as you can see in the screen. The SCL of Arduino will be connected to SCL of all the respective I2C enabled devices and SDA of Arduino to the SDA of those devices. In Arduino UNO, analog pin A4 acts as SDA pin and A5 acts as SCL pin. Like previous case, avoid using these two pins for other purposes while they are acting as I2C pins. We will see practical demonstration of I2C communication in later videos of this video series. Now keep in mind that this I2C communication needs two lines, that is SCL and SDA. But in this case, unlike the UART communication, it is a one-to-many communication. Now let's move on to another communication protocol, that is SPI or Serial Peripheral Interface. In this communication, 4 lines are required, namely SCK or Serial Clock, MISO or Master In Slave Out, MOSI or Master Out Slave In, and SS or Slave Select. Like I2C, you can communicate with multiple devices including microcontrollers, sensor modules, display modules, etc. In this case, Arduino UNO will act as master and all other devices, even another Arduino UNO, can act as slaves. The SCK, MISO and MOSI lines will be connected to same pins for all the devices. But only slave select, that is SS pins, in the master device will be different for different slave devices as shown. Data from master and slaves can be transferred simultaneously through the MISO and MOSI pins. However, master will decide which slave to be communicated via the SS pin. In the schematic as shown on screen, if master Arduino wants to communicate with device 1, it will keep SS1 low, keeping other SS2, SS3 as high. Likewise, for communicating with device 2, SS2 will be low and other SS pin will be high. and so on. Keep in mind that for SPI communication, the SCK, MISO and MOSI pins are dedicated digital pins 13, 12 and 11 respectively. However, the SS pins can be any other pins of your choice. We just need to declare accordingly in the code. We will see a demonstration on how SPI works in later videos. As of now, we have discussed 3 serial communication schemes: UART via receive and transmit pins, I2C via SCL and SDA pins, and SPI via SCK, MISO, MOSI and SS pins. Now let's talk about another special feature of microcontrollers, that is interrupt. As a brief introduction on interrupts, consider an instance when you are chatting in your phone. Now suddenly your phone rings. Now you will pause the chatting and receive the phone call. After hanging up the call, you will again resume chatting. Likewise, there might be instances when we want the microcontroller to halt its ongoing program and execute a different set of instructions if some input is fed to it. To have this feature, we have interrupts. There are 2 kinds of interrupts, that is hardware interrupts and software interrupts. In both the cases, whenever an interrupt is triggered by means of hardware input or by any software means, the processing unit which was handling main program at that time stops executing that and starts executing a special set of instructions, and that is called interrupt service routine. After executing the ISR, the processing unit again resumes the main program where it halted earlier. We will discuss about hardware interrupts here. Arduino UNO has 2 dedicated hardware interrupts on its digital pin 2 and 3. If you want a dedicated video on interrupts, let me know in the comment section. So far we have covered the entire pinout diagram of Arduino UNO and discussed about their respective functions. We have also seen some communication schemes that Arduino UNO uses to communicate with other devices. We have also discussed about analog to digital converters and interrupts as well. That's almost all about its hardware configuration. In the next video, you will see how to install software in computer to write codes and upload it to the Arduino UNO. So that's it for this video. Stay tuned to my channel for upcoming videos and do like, share and subscribe to this channel if you find my effort helpful. Also, don't forget to press the bell icon to never miss an update from this channel. Stay healthy, keep loving technology and keep encouraging me. Your feedback in the comment section will be highly appreciated. Thank you.